Hi guys, so we're going to talk about some probability rules. We're going to calculate probability of certain events given a diagram, understand and apply probability notation and symbols. That's going to be a big part. And then we'll talk about the OR rule to calculate what we call union probabilities. So we're going to start off by talking about unions and intersections and what that means in terms of a Venn diagram, and look at some symbols as well. So last time we talked, or during class, we talked about probability of an event happening versus it not happening. And one thing we have to be careful, we talked about like drawing the beads and finding probability of different events. So in that situation, probability of drawing a red bead is whatever, but that one bead cannot also be a different color. So our probabilities were kind of completely separate. They didn't overlap at all. Red and blue were different color beads that didn't overlap in that situation. But a lot of times we have probabilities that do overlap, or events that do overlap. So maybe the probability of A is this circle right here. Probability of B is this circle right here. And then there are some places where both A and B can be happening simultaneously. So we call that an intersection. So when we talk about probabilities and the probability of certain events occurring, we kind of have to keep in mind that sometimes there's some overlap. And that's going to maybe affect some of the ways that we calculate probabilities. So we're going to start with looking at some basic symbols and probability notation and talking about what that would visually look like on the Venn diagram that we have here. So probability of A would include everything in the A circle, even the part where it's overlapping with B. That probability of A, when we say that in statistics, we're talking about the entire probability of A. So not just A, but anywhere where A is occurring, even where it's overlapping with another event. So similarly, probability of B would be the entire circle of B. Probability of A and B, so this upside down U shape is the intersection symbol, right? It means probability where both things are occurring simultaneously, and that would be the overlap area. So let's talk about some other things. We talked in class about the not probability. So that C little exponent means complement. It tells us the probability that an event does not occur. So the probability that A does not occur would be everywhere except for in the A circle, right? And so I'm also including these outer lying areas that are outside of both A and B. So everything that's not A is this one right here. So then I looked at, okay, what if we looked at the intersection between not A and B? So remember what that looked like, right? This was the not A, and then the B was everything in the B circle. So we want to know where those two things overlap. So that would be the section right here. So it's not A and it's B. So that would be the area that's just B, not the overlap, because we want it to be not A. So not B would be everything that's not B. So A and not B would be just the A. So we're kind of looking at some of those symbols. So then not A and not B, the A complement and the B complement, would be where those two things intersect. So basically everything outside of both circles. So then we come to this symbol right here. So that symbol that's the right side of U shape stands for union, and this is where we might call it OR. The reason we call it union for OR is it has to do with kind of unioning them together. We're looking for kind of the both. So A or B is how we pronounce that, and that would be everything included in both circles, including the overlap area. So all of A and all of B, including the overlap area, would be this probability here. Okay, and that overlap area is going to be important later, and it's something that we'll talk about. So then we have maybe probability of A or not B. So we want everything in A unioned with everything that's not B. So that would include all of this area. So everything in A unioned with, meaning also add on anything that's not B. So we are using that overlap area because this is a union, right? Union is not an intersection. We're not looking for where those two things intersect. We're kind of unioning them together. We want all of those things combined. So we could play with this all day and look at all kinds of different probabilities in that Venn diagram, but hopefully that gives you a little bit more of an idea of what we mean by the and the or, the union and the intersection, but also some of that notation and those symbols that we use. So now we're going to talk about the OR rule that is given to us on our formula chart for statistics and where it comes from and how we would go about calculating it. So the OR rule says, is the union rule. So anyway, sorry, I got distracted there. So in this example, suppose that a check of 100 randomly chosen classrooms at McNeil reveals that 38 of the classrooms have refrigerators, 53 have microwaves, and 21 have both a refrigerator and a microwave. So there's kind of two ways I can approach a situation like this. One way would be to make a Venn diagram. So I have a little circle here. I kind of set up my background area, and then I have my refrigerator circle and my microwave circle. So if I kind of fill in some of the numbers, I'm going to start with the overlap because that's kind of the clearest number. So that overlap area, the number of classrooms that have both appliances is 21. Now remember that when we talk about refrigerator, right, we're talking about the entire circle. So when they say that 38 of the classrooms have refrigerators, they're talking about everybody who has one, including anybody who has both a refrigerator and a microwave. So when I put this number over here, what might be helpful to me later is if I think of this number over here as just the people who have a refrigerator. So I'm going to do a little bit of math. I know that this entire oval circle needs to include 38, and I already have 21 accounted for in the overlap. So we know that there's 17 over here who have only a refrigerator. Similarly with microwave, we know that 53 total have microwaves, but 21 are already accounted for in that overlap. So I'm only thinking about those people or those classrooms that have a microwave only. So I do a little math, 53 total, we have 21 in the overlap, so 32. So then if I look at my numbers, I know that there were 100 randomly chosen classrooms, and so far I've accounted for 17 plus 21 plus 32 classrooms total so far, which is 70, which means there are 30 other classrooms that don't have either. They're kind of in the outside of both circles. And those people matter too, or those classrooms matter too. So that's going to be part of kind of our probability discussion. We want to make sure we know that there are people, there are classrooms, there are situations or events that are outside of both circles. So let's actually answer a question with this, an OR question. So it says, what's the probability that a randomly chosen classroom has a microwave or a refrigerator? And just so we can put this in probability notation, we'll say that we'll let M represent the event has a microwave, and we'll let F for fridge represent the event has a refrigerator. So I'm finding the probability that a classroom has a microwave or, that's the union symbol, a refrigerator. So when we talk about OR and we're looking at a Venn diagram that's set up this way, right, the OR would mean anybody who has just a microwave, anybody who has just a refrigerator, and anyone who has both. That was what OR means. OR essentially in statistics means, or union means one or the other or both. We're unioning those two things together and accounting for everything within both circles, including the overlap. So I'm going to have 17 who have a refrigerator, 32 who have just a microwave, and then we have 21 who has both. All of that would be included in the OR. So 17 plus 32 plus 21 out of 100 gives me 70 out of 100, which is 0.7 or 70%. So 70% of classrooms have a refrigerator or a microwave. And again, in statistics, OR is referring to one or the other or both. We're unioning those two things together. So let's look at if I looked at this a little bit of a different way. So maybe I didn't feel like drawing a Venn diagram. Maybe that's kind of weird in my head where that comes from. So maybe I want to put this information or even have this information. Maybe it's given to me in a table. So that's usually what happens if we're using a two-way table like this. It's usually given to us to begin with, but you can take information like this and put it into a table. So I set up a table where on the top I have one variable, whether or not someone has a microwave, and then our classroom has a microwave. And then on the side, I have whether or not the classroom has a refrigerator. And then I did go ahead and put on my total row and columns just to make things a little easier. So I'm going to start by putting, there's 100 classrooms total that we're looking at. So we know my total totals should add up to 100. We know that 38 total classrooms have refrigerators. So I'm going to put 38 in the total column for refrigerator, total row. Then we know 53 total have a microwave. And then we know 21 have both. So 21's kind of in that intersection of microwave and refrigerator, right? Excuse me. From there, I can kind of fill in the table just using basic math. So I know that 47 must not have a microwave, right? Because there are 100 classrooms total, 53 have a microwave, so 47 don't. And I can kind of fill in the rest of the table just by making them all add up to be what they are, just some crazy math. So now we have this table, and again, we're answering that question of what is the probability that a randomly chosen classroom has a microwave or a refrigerator. And again, in statistics means one or the other or both. So again, we're starting with P parentheses M union R. Right? So this time we might have to look at it a little bit differently. So maybe I'm saying, okay, I have 38 total refrigerators and I have 53 total microwaves. So I would add those two together because or means add, because we're unioning them together. But if I do that, if I add 38 plus 53, because those are the total amount of refrigerators and microwaves, what happens is I end up with counting these 21 classrooms that have both are getting counted twice. They're part of the 38 and they're also part of the 53. Okay, so what I have to do is I have to subtract 21 because I don't want them to count twice. I'm not trying to take them away. I'm not saying those doubly or those overlap people or classrooms don't matter. I just don't want them to count twice. They don't matter more than other classrooms. So I have to take them out because I've added them in twice. Out of 100 is 70 out of 100, which is 0.7 or 70%. So we're getting the same answer. Right, so the reason I'm showing it to you this way is A, it can be helpful to think of it this way when you're given a table. So I can kind of see if I'm looking at totals, I need to make sure and subtract out the overlap so that they're not counting twice. But it's also important to know it that way because that is our official formula for union or that's given to us. So the or rule says probability of A or B, union B, is equal to the probability of A plus the probability of B minus the probability of A and B, or the intersection of A and B. So in other words, right, or means add, right? We add or union the probabilities together, but we have to avoid double counting, right? So that overlapped area is counted in part of the A and part of the B. It's counted in both, so I have to subtract it once so that we're not double counting it. So that's essentially what our rule says, and we kind of saw that with our example here. So we have 38 plus 53, but we didn't want to count the 21 twice, so we subtracted them. And that's where we got our final answer. One thing to note is if you have a situations where your events don't overlap. So if there's like picking the beads from the example in class, if I'm doing probability of picking a red or a blue bead when I pick one out of the hat or container of the beads, a single bead cannot be both red and blue. So there's no overlap there at all. So we wouldn't have to worry about this third piece, right? And when there's no overlap at all within two events, we call those two events mutually exclusive or disjoint. So that would mean it's impossible for those two things to happen simultaneously. There's no overlap in those two probabilities. So it just means that we don't have to worry about subtracting that and piece at the end. So that is something that is good to know. All right, so what I want you to do now, and this is going to be due next class on Monday or Tuesday, is to complete the Desmos activity that's linked in this assignment. So where you got this video, go back to Schoology and find that assignment, and there should be a link to a Desmos activity that you're going to just do on your own that gives you more practice with these symbols and also with the OR rule. So that is what you need to do, and yeah, I'll see you guys next time.